Welcome to today's webinar, Getting Started with Continuous Delivery on AWS. Our presenter today is Chris Munns. Chris Munns is the Business Development Manager of DevOps at Amazon Web Services based out in New York City. Chris works with AWS customers to understand how DevOps culture, practices, and tools can help them to improve their organization's development and operations capabilities. Prior to his role, Chris spent a number of years gaining cloud operations and architecture experience as a solutions architect at AWS, as well as holding senior operations engineering posts at Etsy, Meetup, and Hinge. Today with us, we also have Mikhail Prudnikov, solutions architect, and David Nasi, senior product manager, as our webinar moderators, who will be engaging with you and answering your questions throughout the presentation while our presenter presents. Chris, welcome. The floor is now yours.
Hi everyone, welcome to today's webinar, DevOps on AWS, Getting Started with Continuous Delivery. My name is Chris Munns, and I'm the Business Development Manager of DevOps here at AWS. Again, I want to thank you for joining, and with that, we're going to get started. So why are we here today? So continuous delivery has become a very important topic in the world of software development and in delivering product to the world and your users. Software moves faster today, right? And that's something that's very easy to understand given the highly connected world that lives around us. Software creation distribution is way easier and faster than it's ever been in the years previous and continues to get faster every single day. Because of these changes and because of some of the things we'll talk about today, startups can now take on giants with little to no funding ahead of time. Because of cloud computing, companies no longer have to worry about raising large rounds of money to buy and purchase equipment in order to take on technology companies. And as well, alongside of with the devices that we have today, getting your software into the hands of millions is just a download away. Then lastly, for larger established companies, your ability to move fast is paramount to your ability to fight off this disruption. Given that any small startup could potentially take on a giant multi-decade long company with very well-established products with very little ramp or time ahead of time in developing the product. As an existing company with an existing product, your ability to react quickly to the market's needs and to the needs of your customers in as fast as a way possible is very much tied to your survival. And talking again a little bit here about the software delivery model, what we see here compared to what we used to have compared to what we have today, it used to be that you had to get in your car, drive out to a store, walk around that store, find the software you were looking for, go up to the cashier, pay for it, get back in your car, drive home, take the disks, install on your computer. And so you're looking at potentially a multi-hour time frame in order to get software that was pre-created for you. When we look at the way the world works today in the software delivery model, what we see again here is maybe seconds of time that it might take for a user to open up, say, an app store type of an app, or go to a web page, or download something via another built-in application delivery model, and very easily get software very, very quickly. And so the ability to distribute this from the producer side, also much easier, as well as the consumption side. And so with things moving so fast today, there are a number of tools that you need in order to keep up with this. So releasing software in this new world requires at least three different things. Tools to manage the flow of your software development release process, right? How are you going to track this development? How are you going to attempt to speed up this development? How are you going to attempt to basically keep product going out the door as quickly as possible? Tools to properly test and inspect your product, your code, whatever it might be, for any sort of defects or potential issues. So we want to make sure that the product that we're shipping works the right way, that it works well, that it's performing well, and that it's as free of bugs as possible. And then lastly, tools to actually deploy these applications. So how are we going to take applications that might be living on a web server or even something that might be downloaded through an app store and make it really easily available in, again, as efficient and error-prone of a way, as non-error-prone of a way as possible. So first we need to understand a little bit about software release processes. And I often like to joke that releasing software should be more like making donuts than building cars. We want to make it very simple and very quick to get out our software such that we were stamping them out much like this picture here types to relate to. We want our software release process to, in a sense, almost be boring. We want it to be quick. We want it to be easy. We want there to be as little surprise or disruption as possible. and really just want to continue to get our new product and features out the door as rapidly as we can for our customers. In talking about software release processes, we see that there are 4 major phases that exist in the flow of building and releasing an application. The first, the source stage, the second, build, then test, and then production. And you can think about how these are all represented pretty straightforward in ways that you'd expect. In source, you're going to check in your source code, maybe say Java files or whatever your application code might be in. Maybe there's some sort of peer review process that you might have in your organization or some way that someone else on your team might go to check to make sure that your code is accurate. In the next phase, build, maybe your code requires compilation into a binary. Maybe it requires being built into a container image. Maybe you need to build an iOS or an Android or some sort of other App Store-based model package. This is also where you'd potentially run unit tests, potentially run style checkers, potentially generate code metrics around the change of your code and the performance of your code and other aspects about it. And so a pretty typical phase to want to iterate our code through as quickly as possible. In the test phase, we actually want to take our built product, our compiled code, our code ready to be tested, throw it out into an environment where it can actually be acted upon, whether this be an environment that has stubs on either side for testing, or is a deeper integration environment which may have other systems that it might talk to. And this would include doing things such as load testing, UI tests, penetration testing, or other security testing that might be related to your application. And then lastly, we want to deploy this to production. And again, depending on what your product might be, this could be everything from deploying code out to a server to deploying code out to an app store where it could then be consumed by your customers. So while there are 4 major phases, we also see that there are different levels to how you might work through these phases. The first is continuous integration, which is the concept that on every time that code is committed, that code is going to be built and tested. Again, the raw code here. And this is something that you should be trying to do as often as possible. If you're doing things such as nightly builds or weekly builds or some sort of other longer span increment, you're actually going to miss out on a lot of the benefits and the capabilities of the tooling that we're going to talk about today. The next step up from this is continuous delivery. With continuous delivery, the idea here is that you've gone through continuous integration, and then you're taking that code that has been built or lightly tested already, and at least moving it out through a test phase on some other system. And then potentially after some sort of testing review or manual step or someone clicking a button, there's some sort of a gate that might live between the test phase, some sort of staging phase or pre-production, and then a production environment. So this concept of there being some sort of thing that needs to happen manually in order to allow the deployment up to, again, whatever production might be for you. And then lastly, there's continuous deployment. And continuous deployment takes continuous integration plus continuous delivery and completes the process by automatically moving code out to production on every run. So this would be an example. Every time a developer commits code, it is built, it is tested, and then it is put into production. And this really requires you to spend a lot of time becoming as capable and as well practiced as possible with continuous integration and delivery in order to enable continuous deployment to be beneficial for your organization. And so in today's webinar, we're going to be focusing primarily just on continuous delivery. So again, this second option here is basically our focus today. So what are the benefits for continuous delivery? Well, there's a number, and actually they kind of build off of each other. The first is to automate the software release process. By automating the software release process, we can make the motions or the actions of releasing software very straightforward and repetitive for everyone in the organization. By removing friction from the process, it allows us to greatly speed up our ability to get code out that has been tested and that has been reviewed. Because of this, we can improve developer productivity. If developers are able to quickly release code, then they're able to quickly get more product out to market in a quicker time frame. We're also able to then quickly address bugs, and then lastly, again, deliver these updates faster because we're addressing bugs more quickly and developers are able to produce code more quickly because they're testing more often. So again, by combining all of these benefits to continuous delivery, you can really see a huge change in your company's ability to get your product out to market. So we've covered some of the benefits of continuous delivery and given a little bit of an introduction here to what we're going to be talking about today. What I'd actually like to do is step back lightly and take a look about how development has worked here at Amazon. So here at Amazon, we've gone through a number of different phases of the company over the last 20 plus years. And I talk about one of the biggest transformational shifts that we had at Amazon. So get back to 2001, Amazon.com was a monolithic application with a large monolithic development organization behind it. And you can think of it in the way that many large enterprises do development today. We had one large code base, we had one large development team that was then working on that code base, building into it multiple functions, multiple capabilities, multiple user flows, but again, still kind of working in that one stream. And so as we grew in size, we realized that we had to change the model in which we operated in order for us to operate and move and produce more efficiently. So what we did is we shifted the organization from this monolithic application and these monolithic teams to what is today called microservices, and then to what we internally call two pizza teams. Essentially the idea that there would be small teams of people focused on an individual problem, these microservices, and then they would build these all independently in parallel without having to worry about the types of slowdowns and blockers that we saw when we were operating in a more monolithic way. And now this topic here we could spend the entire day talking about, and it's not the focus of this actual webinar, but just understand that by moving to this model, we were able to greatly improve our ability to move at a much more rapid pace. So again, things were going really well. We were developing features faster than ever. But here at Amazon, we like to say that we're vocally self-critical, and we like to do introspection on ourselves every now and then, to understand what we could be doing better. And so taking this into account, in 2009 we ran a study to find out where the inefficiencies might still exist in our development practices. All right, given that we had broken down our teams, broken down our products, and we're now operating in a highly parallel fashion, what could we do to actually make this better? So we started analyzing what it was that individual teams were doing and working on their projects. And we found that there were a couple of common attributes and patterns to them. And one of the biggest things that we found is that we were primarily just waiting around. So if we looked at kind of the development flow that would exist, we had people who were writing code, then they were building that code after waiting a while, then they would wait until they can deploy it, and they can wait till they can deploy to production. And part of this was due to handoff, part of this was due to resource consumption, part of this was due to having to wait for someone to come and check work, part of this was due to having to wait for quality assurance and testing to happen. And so what happened here is that while the actual work that we were doing was taking minutes, the waiting was potentially taking days. And when you combine all of this together for the products that we were building, it was taking weeks for us to get a product out in front of the end consumer of that product. And realistically, when we were thinking about it, the fact that the actual work being done by people was only minutes, the fact that it was taking us weeks to get our product out the door wasn't really acceptable. What we really wanted to do was get this down to hours. And so we looked at all the products, we looked at all the pieces, we looked at all the waiting, we looked at all the commonalities between them, and then we realized that what we needed was some tooling to solve this problem. And so what we built were a number of tools to help us automate our software release process. And one of the first tools that we built to help with this was a tool that we internally called pipelines. And so what pipelines does is it helps automate all of the actions and transitions from check-in to production. And we saw a number of benefits with this, such that development would now be faster. It could also be safer because we were enforcing that testing happen throughout this process in an automated way. It offered up a consistent and standardized tooling flow for the internal development teams at Amazon to work with. So that meant that a team could go from one project to another with the same tooling. If people came into the team from other teams or they changed teams for some reason, they would still see the same tooling. And so this offered up, again, this ability for developers to very easily understand what the development pipeline looked like for any team inside the organization. And then lastly, there's a visual component to this. And so it's very easy to go and look at this pipelines tool and understand what steps there are in any team's delivery pipeline. So here at AWS, Amazon Web Services, one of the things that we've done over the years is taken the internal tools that we've built at Amazon and make them into AWS services. In this case, in the summer of 2015, we released a service called AWS CodePipeline. And so AWS CodePipeline is based off of the tool that we built internally, Pipelines, that's been running at Amazon for many years now. So what AWS CodePipeline does is it offers up continuous delivery service to allow you to have fast and reliable application updates. It allows you to model and visualize your software release process. So again, it has this visual aspect built into it. And it allows you to automate the process from check-in to production deploy, including builds and tests, and any other sort of environment deploys that you might have every time that there's a code change. And then lastly, one of the key aspects about this tool is that it integrates with a number of third-party and other AWS tools. And we'll talk about some of those integrations here today. Thinking about some of the benefits for CodePipeline, it's a tool that has a very highly configurable workflow. So whether you were building a web application, an API application, a desktop application, a mobile application, or basically kind of any application that you could think of, you can configure the workflow to meet the needs of your application. We make it very easy to integrate. We'll talk about some integrations a little bit later on here in today's webinar. But essentially, we provide two different methods out that you can integrate with software, whether it be software that you're writing, software that you're taking from third parties, or other services that you might be interfacing with. Because we can automate a pipeline, you'll end up with improved quality based on the fact that you could constantly be running tests as part of CodePipeline. And so development teams that are automating, again, the delivery process will see the benefits of this. This allows for rapid delivery because of this automation, removing the manual handoff periods that might exist, helping to keep people away from having to rewrite tools every time they build a new application. And so because of this, you can get started really fast with using CodePipeline. So now we've talked about some of the benefits. Let's take a look at what CodePipeline actually looks like. So we see here an example of a CodePipeline. This is kind of a mock-up of what it looks like in the web console. And what we have here is a pipeline. This pipeline is made up of 3 stages. And then each stage in this example has a single action. Actions are connected to each other with transitions. And so you see here that this 3-stage, 1 action per stage pipeline has 2 transitions between it. So we see here an example again of a single action per stage, but there is a lot of customization that we can do with CodePipeline. For example, we have the ability to run parallel actions. We also have the ability to run sequential actions inside of a single stage. So we see here now in my build stage that I have 3 different actions that I'm running, 2 in parallel, and then 1 sequentially after that first 2. And again, you as a developer have the ability to modify this to meet the needs of your application's delivery patterns. Let's talk a little bit about what a workflow would look like with CodePipeline and how it is that it interfaces with other services. So let's say that I'm a developer, I've been writing my code, and now I'm going to commit my code back to github.com. So I hit git push, and up my code goes. Behind the scenes, CodePipeline is polling github.com looking for changes. When it gets those changes, it's going to then download my most recent commit as well as the most recent kind of head on the master branch or whatever branch you might have selected for my repository. And it's then going to create a source artifact in S3 for me. And then from here, my source stage and source action are done. CodePipeline is going to kick off the transition for the next stage, which is going to be a build stage. In this case, I've got Jenkins running somewhere on EC2. And we provide a plugin for CodePipeline for Jenkins. So you can go and download that from the Jenkins plugin site. In this case, the plugin and Jenkins are actually going to be polling CodePipeline looking for work. When it finds work, it's going to acknowledge that job. In this case, I've got a Java application, so it's going to grab my source artifact. It's going to compile it for me, maybe run some unit tests and some other tests. It's going to then build that artifact based on that work, and then shoot that back out to S3 for me. And then from here, it's going to put back a success on its work back to CodePipeline. Now I'm ready to transition on to my last stage, my deploy stage. In this case, I happen to have my Java app running in Elastic Beanstalk in a web container. And so what CodePipeline is going to do is it's going to go and find where my build artifact is. It's then going to tell Elastic Beanstalk to deploy that build artifact. And from here, my pipeline is done. So what you've just seen is a workflow example. As a developer, all I've done is commit code. Behind the scenes, CodePipeline has interfaced with 4 different services: github.com, S3, Jenkins, and Elastic Beanstalk. And I could have a much more complicated scenario here if necessary, but hopefully you get the idea on how you plug in many different things to CodePipeline in order to meet the workflow needs that you have. And we have a really very strong partner list continuing to grow here. We're always looking for other companies that would like to see their products integrated. So we have a number of different source products, build, test, and deploy partners that all integrate with AWS CodePipeline. as well as having a number of other AWS services that integrate with AWS CodePipeline. So from source actions, we have S3 and code commit. In invoke logic, we can invoke Lambda. And then in deploy, we can use Elastic Beanstalk or CodeDeploy to actually deploy our code out to other AWS services. So let's go through what it's actually like to build an application release pipeline using CodePipeline. So here we are at the CodePipeline console on the landing page. So you click Get Started. From here, then, we can name our pipeline, pretty straightforward. So I'm going to call this one Webinar Pipeline and click onto the next step. And then from here, I get to choose my source provider. So today we have 3 built-in source providers in the console: AWS CodeCommit, Amazon S3, and GitHub. In this case, I'm going to select CodeCommit. From here now, CodePipeline actually goes and populates my repository name and branch name with things that I can see are already in my account. So it makes it very easy for me to go and click and select through. I happen to have an example application here named Soups for Dogs, and then this happens to be in the master branch for this repository. So this takes care of up to the source phase. When I click on the next step, what I would go to is the build phase. And so we're going to talk real quickly here about some background about building and testing your application. So again, when it comes to building your application, we're typically referring to languages that require some sort of compiled binary. This could be .NET languages, Java and JVM languages, languages for mobile applications, Go, a number of other languages that are out there today that require some sort of compiled binary artifact that you would then deploy to a server, a host, or a device. We also, when we use the term building, refer to this as the process of creating a Docker container image. So you'll see building used in both of those places. There are many languages, though, that don't require building. So languages such as PHP, Ruby, Python, Node.js don't require any sort of compilation or building into an artifact. These can just be deployed directly onto a host and then processed by some sort of an interpreter that might live in your web server, say Apache or Nginx. And so in this case, we can just take that and deploy it, and this wouldn't necessarily be a build step as much as it would just be a testing step. When it comes to testing your code, testing is a pretty sophisticated topic into of itself, and so I like to say that it's both a science and an art form. But there are a number of goals that you'll want to accomplish in testing your code. You'll want to confirm that you have the desired functionality. So this is one of the most basic kind of things that you'd want to do, is to make sure that your application is actually providing the capabilities that you're looking for in terms of the UI or the API or however it might be that people might be interfacing with it. You're going to want to try to do things like catch programming syntax errors. And actually a great place to start is just running a basic linter on your code to make sure that you're not missing things such as missing quotes or brackets or parentheses or commas or whatever it might be depending on your language. This is also a good way to standardize on code patterns and format. And so in many organizations, standardizing on a code pattern or format is a great way to help make sure that your developers are all producing code that can be read by other people. And this is a key aspect of allowing for things such as code reviews, is to make sure that everyone is coding within the same standard. Lastly, hopefully, by writing tests for your code, you'll be able to reduce the bugs due to non-desired application usage and logic failures. For example, if people are only supposed to be putting in numbers into a certain field, when they put in letters, what would happen? Ideally, your application would catch this, but if not, you would want to make sure that your application wouldn't crash or see some sort of an error based on this. And then lastly, when it comes to testing your code, there are a number of tools that you could use to make your applications more secure. AWS Inspector is a great example of a tool that you can use that will look at your hosts, your application, and help find potential issues that might exist from a security perspective. So going back to CodePipeline here, we're going to add a build step to our application. In this case, we're going to use Jenkins, an open source continuous integration server. I happen to have a Jenkins instance up and running, and so it has a URL. I also have a project name that exists, and I'm going to give this a provider name that correlates with the pipeline that I'm creating. So now that we have a build stage put in place, the next thing would be to have a beta environment, which is typically part of the integration or deeper functionality testing that we might do in this environment. So let's talk real quickly about how we might want to deploy to that beta environment. At AWS, we've got a number of different options when it comes to deploying your applications. We're going to focus on just one here today, AWS CodeDeploy, which is another tool in AWS's code services. So with CodeDeploy, essentially what it does is it acts to help just to deploy code out to servers, essentially to move the bits from A to B. And CodeDeploy is actually also based upon an internal tool from Amazon, which is called Apollo, much like how CodePipelines is based on pipelines. And now Apollo is a tool that's used by almost every developer inside of Amazon that is deploying code that lives eventually on some sort of an instance or physical host. So with CodeDeploy, it's an agent-based service. You install the agent on your host. This host could be Linux or Windows. This agent could live on a host that's either on AWS or off AWS, and it supports any language that you could potentially interface with. We also have a number of integration points with third-party tools and other AWS services, such as CodePipeline. Now, I mentioned that CodeDeploy uses an agent to run itself and to execute actions on your behalf. In this case, this agent needs an instruction file. That instruction file is called an appspec file, or the appspec.yml, which we see an example of here. Now, the appspec file has a standardized structure that you need to follow in order for the agent to perform certain actions. And with CodeDeploy, we see the agent's capabilities and what would happen in a deploy being a lot more than just moving the bits from A to B. It might be moving the bits from A to B, but then where B is, you might actually have several directories that you need to put different parts of your code in. You might want to set individualized permissions on certain parts of that data. And then lastly, we have this concept of lifecycle hooks. With these lifecycle hooks, we have 5 predefined times in the lifecycle of a deploy that you could execute scripts that could perform any number of actions. So we see here in this example are scripts that can deregister an instance from an ELB, then we can install our dependencies, then we could start our web server process, then we can test it in the validate service hook, and then lastly we can re-register with an ELB. And now why this is very important is because it can enable us to remove this host from taking user-facing traffic during the deploy and then adding it back after everything's been successful. And so with this, we can reduce the impact that our users might feel when it comes to seeing a deploy happen. Another big part of how CodeDeploy enables you to reduce the downtime that could potentially happen because of a deploy is via rolling deployments. So what we see here now in this example is that we have a deployment speed and we have 6 hosts. So I could deploy to these 6 hosts one at a time, half at a time, all at once, really any integer or percentage-based value that I want to set. In this case, what happens is the CodeDeploy service will only key up work for the hosts that are represented by the speed that you choose. The agents on those hosts are pulling CodeDeploy, looking for work to do. When they find that there is work for them to be done, they will go and download whatever the deployment artifact is that's been specified. They will look for the appspec.yml file, and then they will follow inside of there the lifecycle events as well as the files and permissions values that you have set. So this example that we have here with one at a time, where we're just deploying to one host at a time, as long as the deploy is successful on each host, it will continue. But if it were to fail on this first host for some example, let's say maybe there was a bug that we didn't catch in our testing, CodeDeploy will actually stop the deploy. What this means is that if this first host potentially was not taking traffic or only taking some part of our traffic, we would have greatly reduced, if not completely blocked, any sort of impact to our users in seeing this failed deploy. And so again, because of this flexibility, you have the option of choosing the speed that matches what the needs are of your application and the scale of your infrastructure. On the other side here of the slide, we see the concept of deployment groups. Now we see CodeDeploy being a service that you should be able to use the exact same way, whether it was in development, staging, pre-prod, prod, whatever you might call your environments that your instances might live in. In this case, there are 2 different ways that you can tag, or that you can reference instances as part of a deployment group. One is via tags, and one is via autoscaling groups. In the case of tags, you have the tags that might be referenced by EC2, or if you're using CodeDeploy on-prem or in another hosting environment, when you install the agent, you actually get to define tags at that point. The other way that we can define deployment groups, again, is with autoscaling groups. Now, with autoscaling groups, what happens is when the agent comes up on a host for the first time, it will go and it will look to see what deployments have occurred as part of that host's environment. It will then go and do the deploy that was the most recent one onto that group. And then as you deploy out to groups, what CodeDeploy does is it goes and looks for all of the hosts that would be part of an autoscaling group and then keys up the work for them. And then again, your deployment speed specifies where hosts get deployed to. So again, CodeDeploy gives you the ability to essentially do rolling deployments with hopefully no downtime or any impact to your end customers and to your application, while also allowing you to perform various different actions on the hosts that you're deploying to. So going back over to CodePipeline here, what I've done is I've selected CodeDeploy. Now, much like with code commit here in the web console, we can actually populate the application name and deployment group for this CodeDeploy setup and configuration. So with this, I can now go forward and select a service role. In this case, because CodePipeline is going to be acting on your behalf across a number of different services, you have to give it a role that it will have access to, commit and to do those various actions for you. We do provide a built-in role if you don't want to create your own, or if you've created a role, you can here select it. In this case, I have a role that was created for me, and I'm going to use this role to allow CodePipeline to take the actions it needs to take. So now we're pretty much all done with this CodePipeline. Again, only really 5 steps that we have to go through here in order to get the initial pipeline up and running. I now get to go and review, and this page was much larger than what would fit on my screen. But you can assume here that what we have is the information about our source stage, our build stage, our beta stage, and our service role. And now we're good to create this pipeline. Now we see what you would see as soon as you would have created this pipeline. In this case, the pipeline has now been defined, and as soon as I create the pipeline, it's actually going to execute itself based on whatever the most recent commit was to the source that I configured it for. After running through this, in this case, I see a successful execution across my pipeline. What we see are the 3 stages that were defined: source, build, beta. I have the 3 actions that came as part of that. So my code commit source action, my build action with Jenkins, and then my deploy action with CodeDeploy. And one interesting thing that you'll note here about the console is you see these little blue highlighted words that exist. These are actually deep links into the services that are represented here in this pipeline. So if I were to click on the code commit hash, it would actually take me to that code in code commit. If I click on the details button for Jenkins, it will actually take me to my Jenkins host web console and take me to the actual build results. And then for CodeDeploy, if I click on details, it will take me into the deployment details for that deploy. So if anything had gone wrong here, and I would see a red bar instead of a green bar to the left, or to the left of the stage, I'd actually be able to very easily go and inspect whatever it is that might have gone wrong, then be able to potentially hopefully fix it, and then I could potentially then go and release a change again and kick off a deploy. So this is a basic, again, code pipeline that you would get. In this case, that's up through what we would consider to be a beta stage or some sort of pre-production environment. But we obviously want to get our code out to our new users. So let's talk a little bit about launching to production now. So in launching to production, we've hopefully gone through, built our code, we've tested our code. We have a good idea that our code now meets the basic needs that we have. And hopefully we've gone through, again, a couple of runs of this to make sure that we're baking that quality into this process. And so it's very easy for us to add a deploy step, as we'll talk about here in a moment. But there are a number of things that you'll want to think about. You'll want to think about the impact to your customers, the impact to your infrastructure, and the impact overall to your business. And so being the fact that a deploy you can think of as kind of a physical action, how can we track this action and then the results of what comes from it? Well, I talked a little bit about this before, and the idea that CodePipeline is a very, very, very extensible platform. So for example, you could create an integration with a mobile testing tool. You could create an integration that could go and update a ticket, such to say that maybe that a certain feature worked or that it's been deployed or built. You could actually create custom actions to do provisioning of resources, maybe to launch a CloudFormation template or call another API to launch some resources. You could update a dashboard. Perhaps you're using a third-party dashboarding tool that gathers metrics and does monitoring for you, and so you could send an event saying that a deploy occurred. You could also just send notifications to maybe email, a chat program, some sort of other messaging program. And then lastly, you could also perform some sort of security scan against the infrastructure. Maybe you want to use a tool to poke at the application and make sure that it's performing well. So we have 2 different types of ways that you can build essentially custom actions or plugins into CodePipeline. The first is to use Lambda. So with Lambda here executing, you have the ability to run short-running tasks that live inside of Lambda. If you're not familiar with Lambda, Lambda is serverless computing service provided by AWS, in which you don't manage the servers, you just write functions of code that are then executed by the service or other services that can invoke those functions, such as CodePipeline. The other option that we have here is to build an actual custom action. And much like the Jenkins plugin that we provide, the custom action is software that lives on a host that you control potentially, that can allow you to perform maybe a little bit more in-depth or larger types of scale workloads. So comparing and contrasting the two as you see here in this table, there are a couple of things that you'd want to call out. Custom actions are really meant to perform any type of workload interaction that you might want to have plugged into your software delivery lifecycle, whereas Lambda is typically meant for more short-running tasks that are easier to build. You do have the ability to support longer running tasks with Lambda. In this case, we have a concept of what's called a continuation token, but there's a bit more work involved in terms of managing that workflow. Lambda functions today have a 5-minute timeout, and so this is something that you have to take into account in terms of how you would manage a long-running task with it. With Lambda, we support 3 languages today: Node.js, Python, and Java, whereas a custom action could potentially be done in any language that you wanted it to, as long as it spoke the API that CodePipeline uses for its interfaces with third-party actions. Lambda only runs on AWS, whereas a custom action could run on-prem, another cloud provider, another service that you might be interfacing with, and so it gives you a little bit more flexibility from that perspective. However, when it comes to the ease of management and the overhead involved, Lambda has no servers to provision or manage, whereas a custom action would require some compute resources somewhere running that code. So we've got our pipeline again here, 3 stages, and now we want to go and actually add another stage. So let's look at what it's like to add another stage here into our code pipeline. So I'm going to click on the Edit button. From here, I now see the ability to go and modify my pipeline. And what I'm going to do is add a stage right below my beta stage. So I've added a stage, I've named it production. Now I'm going to add an action to that stage. In this case, I'm adding an action which is a deploy. I'm going to again use CodeDeploy for this. I'm going to select my same application name, and then this time I'm going to select the production environment as opposed to the development environment, which I used for my beta stage. So now that I'm done, my CodePipeline stage for production looks like this. And as you can see here, I could very easily add an action in parallel or in sequential flow either before or after the action that I just added. But in this case, I don't need to. Everything is good, and so I'm going to go ahead and click OK on these changes. So now what you see is my pipeline as it is finished. I've got 4 stages, 1 action per stage, and you can see here how the very last stage, my production stage, does not have an execution. Now, because I've already gone through my pipeline in its initial execution when I first set it up, maybe what I'd like to do now is go through the entire flow. Excuse me. In this case, this is what the release change button does for me at the top of the screen. I can go now, click on release change, and what will happen is CodePipeline will kick off an execution throughout the entire workflow. And in this case, going all the way through to my production deploy, deploying out with CodeDeploy, and I'm good to go. So we've seen a quick run through today of the benefits of continuous delivery on a software release process and how CodePipeline can be a big part of it. Continuous integration, that first phase that we talked about, or that first pattern in terms of releasing software, is a really important part of this. Right? We want to be building and testing our code as rapidly as possible as it's being developed. Looking at long integration cycles means that we're giving ourselves more time in between when we've written our code and we've tested our code, and so it makes it more difficult to debug over time. It allows us also to speed out the actual delivery of our software out to our end users, which gives us the ability to potentially pivot or change our direction, to see what types of performance issues we might be running into, or to more quickly react to bugs that might have gotten through our testing process. So by moving faster, we can actually ensure better quality instead of by moving slower. Again, CodePipeline allows for integration with almost any service or tool that you can think of. And we saw a really quick example today of how quickly you can get started Just a couple of clicks in the console and you've got a pipeline up and running and ready to start testing and deploying your code. And again, that visualization really gives you a strong idea of where in the flow you are in your application lifecycle delivery. So in my demo today, I had some pre-created environments. I had a pre-created application and a number of other things that I had kind of behind the scenes, if you will. And what we've actually done is put together a starter kit that you can go and test all of this out. So the starter kit creates a VPC for you with all of the necessary subnets and routing rules and all the other kind of good bits that you would need for kind of a core infrastructure on AWS. It creates a Jenkins host for you that has the Jenkins plugin installed for you. It creates 2 different hosts that are part of 2 different CodeDeploy, one application and then 2 deployment groups. And then lastly, it creates a pipeline that ties all of this together. We provide an application for you as well, just so you can kind of see the full start to end of exactly what I demoed for you here today. And so you could find that here at this bit.ly link or in the AWS DevOps blog, which is where this bit.ly link will actually redirect you to. So as with everything here at AWS, there's much more reading that you could do. You could read further about continuous integration and delivery at the 2 URLs seen here. You can also go and read into more about CodePipeline and CodeDeploy, which we only briefly really kind of talked about today. But there are a lot of examples and a lot of documentation to help you understand some more advanced concepts. With that, I'd like to thank you for coming and joining us here today with our webinar. We hope that you've learned something new about continuous delivery and how CodePipeline and CodeDeploy and the rest of the ecosystem around these tools can help aid you in releasing your software. Thanks again and hope to talk to you soon. Have a great day.